This is part B of this example. We've been asked to integrate sine cubed theta with respect to theta from theta equals 0 to theta equals pi on 2. The previous video, part A, demonstrated how to do this with a trigonometric substitution. We're going to use the table of standard integrals in this part. So first of all, I need to open up my table of standard integrals and look to see which integral I am to use. I've got sine cubed theta as my integram. So looking over at the table of standard integrals, I see that on the right hand side here I have the integral of, there's sine squared, but here, sine to the power of nx with respect to x. It's the same integral as that I need to integrate here, but it's the integral sine to the power of 3 theta with respect to theta. So I've got the integral on the right hand side here. It's got a function at the front here. I need to substitute in n is equal to 3. All my x's are being replaced with thetas, of course. And I have one other integral as part of this solution to do this. As I'm finding the integral of sine cubed, n is equal to 3. The second part of this answer would be then the integral of sine theta to theta, in this case sine x dx, which is just a standard integral which I know I can do. So that's the formula I will be replacing with in using this, in evaluating this integral. Going back to the page, so this is part B. Write out the question again, the integral from 0 to pi on 2 sine cubed theta to theta. I note that I will be just using the table and I can see the integral that I need to use, sine and x dx, but I'll just be replacing the n with 3, so we might as well make a note of that as well, where n is equal to 3. So I can go straight to the answer. While I'm here, I note that this is a definite integral, so I have limits in this integral, whereas the integral on the table is an indefinite integral with no limits. So when I come to evaluate this function, I will have the limits. These are theta values, x values going from 0 to pi on 2, and this integral here will have the same limits as well. So I'm imagining using this integral here, replacing the x with dx, replacing the n with 3, because I want to find the integral of sine cubed. So I'll just translate this over to the other page. It's minus sine n is 3, so sine squared x. Over here we have minus on the top line will be sine squared theta now, multiplied by cos x. So in our example that's multiplied by cos theta. All of that is being divided by n, which in our example is 3. We'll now evaluate that bit in between 0 and pi on 2. So that was not on the table over here, but that's what we have to evaluate. Plus, there's a constant in front of this integral. N is equal to 3, so 3 minus 1 is 2. 2 on 3 is 2/3, so we've got plus 2/3. An integral here, so we'll write down the integral with the same limits, 0 to pi on 2. Sine of x dx, where n minus 2, again, n was 3, so 3 minus 2 is 1. Sine to the power of 1 is just sine x. So in our case over here, we'll replace that with integral of sine theta d theta. So we've still got a integral to do over here, but this is a standard integral, so we have transformed the complicated integral into a standard integral here using the table. We'll need to evaluate the limits here, but we'll do that in the next step. Let's rewrite this out again. Sine squared theta cos theta, all divided by 3, evaluating that from 0 to pi on 2, plus 2/3, the integral of sine theta. I remember my little code. Derivative of sine is cos. Derivative of cos is negative sine. So the integral of sine is negative cos. So we'll put that into here and we get negative cos theta. And I'll be evaluating that from 0 to pi on 2. So now we can start substituting in our limits. That's all the integrations done. Let's take the minus 1/3 out in the front of this first term. So all we're left with is sine squared theta cos theta. Substitute in the top limit. This gives us sine squared of pi on 2 cos of pi on 2. Minus the bottom limit, substituting in, is sine squared of 0 times cos of 0. Sine squared of 0 times cos of 0. There's the first term. Plus this term. Now I've got a minus inside here with the cos theta as well. We can take that outside, and so that will become out the front with a negative 2/3 now. All I'm left with inside the brackets is cos theta. Substitute in the top limit, gives me cos of pi on 2, minus the bottom limit, which is cos of 0. To evaluate each of the trig functions here, I'll remember the graph of sine, the graph of cos. So a quick little diagram over the side. Here's the graph of sine theta. In between 0 and pi there. So sine of 0 is 0. Sine of pi on 2 is 1. This is sine theta. And a little graph of cos theta in between 0 and pi on 2. So here's the graph of cos theta. We know that cos of 0 is 1, cos of pi on 2 is 0. So substituting all the values into our answer up here, minus 1/3 outside of. Sine of pi on 2 is 1, but cos of pi on 2 is 0. So 0 times 1 in this, the whole term is 1. Cos of 0 in this second term is 1, but sine of 0, all squared, is 0. So the first term cancels out to give us 0. The next term here, minus 2/3 outside of cos of pi on 2 is 0. So we put that in there, minus the cos of 0, here it is equal to 1. We put that in there. The first term there gives us 0, minus 2/3 outside 0 minus 1 is negative 1, which gives us an answer of 2/3. If you watch the video that demonstrated the first part of this equation, this integral with the trigonometric substitution, you'll see that we get the same answer of 2/3.